Yeah, I'd like to now introduce our next speaker, Jacob Sherson, who is going to be talking about hybrid intelligence, human centered AI that works in the real world. Jacob holds multiple professorships in management, physics, and if I'm not mistaken, also another one which I was seeing in your bio earlier, which I don't seem to have here. Perhaps you could add that later. And at Aarhus University, physics at the Niels Bohr Institute in Copenhagen University, and is the director of the Center of Hybrid Intelligence and the game-based citizen science platform Science at Home, with more than 300,000 contributors. Jacob is a scientific advisor to public and private institutions on AI and quantum technologies, was a TEDx speaker with almost 300,000 views, and won the 2020 Falling Walls in Science and Innovation Management 2019 Bold Award on Boldest AI plus Boldest Scientific Project, as well as the 2018 Grundfos Prize. Please correct me on this. I hate to get my pronunciations wrong. And the 2017 Ministerial Research Communication Prize. As I was telling the other speakers, I was watching everyone's YouTube videos in the morning. And the one that I enjoyed the most was, I didn't understand it, but I think there's something that you're doing in a laboratory with little mini atoms that you've created with, some very small breadth of hair, part of, something like that. The distance between them is that. And I couldn't understand it, but all I could do was play it again and again, be fascinated. And so delighted to have you here, Jacob. All yours. We'll have questions at the end through a link, which I'll be asking you at the end of your talk. Take it away. All yours.
Okay. Thank you very much for the invitation and for setting up this wonderful conference. And the talks so far have been really, really fascinating. And what I will be doing now is sort of zoom a little bit out from data science and then talk about AI and the future of AI. And I'll talk about it from a technical perspective, an organizational perspective, but also a societal perspective. So I'll just go through a little bit of a journey of what I think that the future of AI is going to be. And my answer is hybrid intelligence. So now, to take a backdrop of what we are concerned with, here is sort of what Deloitte and Gartner and Boston Consultancy Group say, and they sort of more or less say 1 out of 10 AI projects succeed or 9 out of 10 projects fail. And there are a number of reasons why that happens. And what they're saying is that managers in the real world really find it very difficult to integrate these kind of AI systems into people and processes and systems. And Boston Consultancy says that it's not as much important what the AI component is, but it's really one really critical component, and that's the human aspect of that. And all of that sounds, well, pretty scary if you are trying to implement something in a company, and it sounds maybe a little bit untangible if you're trying to do a real solution. So I'll be diving in what I think is behind these numbers. And so one of the ways that I at least understand this now is that with current AI, there are a number of challenges when we try to develop an organizational change. And so one of them is, of course, that AI is developing so quickly that there is what we call a skills gap. So we need to get people out in the real world who have the right kinds of skills to create those kinds of solutions. And one of the things that I will be getting back to is that skills gap is not just about having people who know about the concrete technologies, but also having a holistic view on the solutions created. In addition to that, we have to realize that inside of organization, there is an increasing barrier inside of the organization, the communications gap, that technologies are becoming increasingly complex, and there's a small part of the organization that actually understand it. And then on the other side, we have the news and the media putting pressure on the CEOs to say, we need to do AI and we need to implement it. The technology side, the CTO understands the technology, but then all of the rest of the organizations actually, or parts of the organization, really have very little data knowledge and AI knowledge in order to have that conversation. In the worst of cases, that evolves into something that I sometimes call a tyranny of data, which is that you have a computer scientist or a data scientist who can explain their solution in such technical terms and so convincingly that it's very difficult to say no to it. and very difficult to question the underlying foundations of that analysis because it's based on data, and where all of the objections may actually be based on 10 or 20 years of work experience, where you just have a gut feeling that there may be something wrong about the assumptions, but I just don't have the language to say what I think is wrong about that. And so that means there is an organizational gap there where we have the tech side needing to really understand much more about the business side, and the business side needing to understand much more about the tech solution. So we need that language. The language is what my research is all about, and I'm not going to dive into this, but we're trying to start to have a list of some of the fundamental questions that any kind of an organization need to ask themselves when they are doing a technology transformation like this one, in particular, a high technology AI transformation. I'll get back to this list at the end of the talk. So now I'll just zoom out a little bit and then talk a little bit about sort of the future of AI, and talking about the singularity that I'm sure that many of you have heard about, introduced by Ray Kurzweil, where he really said that if you project the capabilities of current AI systems into the future, then at some point, he predicts in 2045, we are going to reach a singularity, or the AGI, where we have computational systems that can surpass humans, not just on single tasks, but really more or less on all tasks, which is called the singularity. And so one of course, there are many different ways of looking at that singularity. One of my favorite ways of looking at the singularity is almost a decade ago now. One of the very early results coming out of Google DeepMind was that they took a number of old Atari games from the 1980s, and then they had their machine learning algorithm play these games. And of course, they were not taught any of the rules, and it was just self-exploration. And the fantastic thing was that, for instance, this breakout, in a number of sort of just an hour or two of training, then the algorithm had figured out that you just need to sort of carve a hole on the left-hand side there of those bricks, and then the ball comes up at the top, and then it and then it just solves the challenge. And so what I think is really fantastic about this result is the left-hand side of this, where you have all of the 35 different games, and then you have down about 2/3 down, you have a line here, and that is human level or above. Anything above it, the algorithm could solve at human level or above. And philosophically, I think the fascinating part of this is that what we have been seeing, our generation has been experiencing over the past decade, is that this line has gone from us being the masters of the universe and being the best at everything, and then further and further and further down. And the singularity, you could say, might arise in the near future when this curve has gone all the way down and we can play all these kinds of games. So we may be the generation that experiences the singularity. And so in the words of Henry Kissinger and Eric Schmidt in this new book that I can recommend, they sort of draw out 3 examples of how fantastic the advances are in current AI. And of course, you know this just as well as me from all of the kinds of studies. So this is not a thorough review, but just to show what is happening. AlphaZero is one of the things that have been very much in the news. We're applying reinforcement learning to play chess and Go and StarCraft. And again, so the wonder of this is that there is this self-exploration in a very complex space, and that then strategies are starting to emerge that are not generated from humans, but are entirely algorithmically invented. Our small contribution in that field is that a couple of years ago, we took AlphaZero and then applied it to a real-world problem, which was the optimization of something called a quantum computer. And a few months after our result came out, Google DeepMind had a new paper in which they said AlphaZero is really great algorithm. It can be used for games in various different sectors and in the real world. And then they sort of only cited us. So we discovered that we might actually be sort of the first people who had taken AlphaZero out of the games and then into the real world, which was a pat on the back for us, I think. Another thing that I think is really exciting is in the medical industry, where there's something called Halicin. MIT has very recently shown that they can use deep learning to discover new kinds of drugs. And so what is happening here is really that you have machine learning that really understands what the underlying trains on the underlying mechanisms on the effects of the drugs, and then can search through databases, train on thousands of drugs, and then search through databases of millions of known chemicals, and then pick out a very few series of candidates that can be the sort of candidates for successful drugs, and it works. And so that's really fantastic. The last example I want to go is within generative design, where I think maybe some of you have heard about DALL-E, which is this text to image generation, which is really this fantastic merger of ImageNet, where we've now trained on images. We now know computer vision, and then we can merge that with natural language processing, and we can start to just type sentences, and then fantastic kinds of images appear. And it's not just images, it's text to X. So that means we can also start to generate video, music, text, works of art, and other things that are also starting to be commercially relevant. Code in the near future, maybe. So these are trends that I think are really all pointing towards increasing computational algorithms power. I'm sure that you are aware, so that if you categorize the different kinds of machine learning that are happening, and so then you can have supervised learning, unsupervised learning, and reinforcement learning. And what I want you to take from this is just the fact that no matter which one of you have some sort of cost function. And when you try to do it, then you have to optimize that cost function. And I'll get back to that in just a little while, because that's one of the dangers that is happening at the moment, is that the trends that are happening towards AGI is that today we have human in the loop systems where humans are somehow gathering the data, analyzing the data. Then we're moving towards human on the loop, where it's only human verification, and then out of the loop. And there are a number of different sort of very, very dramatic influences of what is happening when we have autonomous operation in systems and they fail when they are applied into the real world. And so here is just an example of one example of what happens when we apply a system into the real world. Oh, let me just see if I can get it working. You have programmed this game and it has some sort of cost function. And unfortunately, you also programmed it to pick up power-ups, and it actually figures out now that the way to optimize the cost function is not to win the game, but actually just to circle around and collect all of those power-ups. So it really shows the danger of only optimizing a cost function, because we may actually be getting that cost function wrong. And hybrid intelligence is all about making sure that the cost function isn't wrong. I talked to one of my good colleagues, UK Chow, who has been working with games, and he says the games industry is really in a set state of crisis right now, because what they're seeing is that they have been micro-optimizing, data-driven, optimizing their gameplay, and it ends with games like Farmville, where no one really wants to play those kinds of games because they are playing on negative human emotions, and it ends with Farmville being a game where you actually pay money in order to avoid playing the game so that you can short circuit into it. So this is an illustration that sometimes humans are not the best people to ask about what we want, because we may not know what we want in the long time frame. Then other kinds of questions that we can ask about data-driven processes that can go wrong is that you have to really be careful when you turn patterns into predictions, into decisions, because there are many things that can go wrong. The environment could be changing. And the second thing is, I really caution you to think about the data that has been acquired and whether it has been acquired faithfully, because very often in computer science, we're seeing that we sometimes fall into this trap of reductionism, that things are put into boxes and then boxes become the pragmatic way of viewing reality, but it actually then becomes our view of reality. And effective computing is one of the cases where this is actually showing that we think that we can recognize emotions, but we can only recognize the boxes of emotions, and we forget the entire complexity of what is underneath, which is the human reality. So what I think is really important in this case here is to learn from failures. So rather than being spectacular and saying here are all of the ways in which AI is successful, we need to look at where it is failing. And when we understand why it's failing and where it's failing, then we can start to build systems that work. And here's just an example from computer vision where there's a stop sign, and then you put these 4 small stickers onto the stop sign, and then the autonomous driving algorithm interprets that as a 45 miles per hour speed limit. So it really shows how human common sense is nowhere near being integrated into current AI algorithms. Another example is that if you took this breakout game here and then raised the pedal by one level, 1 pixel, or lowered it by 1 pixel, then the algorithm would completely break down. And that's because these kinds of deep learning systems, they don't necessarily understand the dynamics, they just see the patterns in the kind of data that we have. I gave my students a 20-minute challenge of figuring out, search the internet and find spectacular AI failures, and it was extremely easy for them. And I just want to draw out one of them that I thought was entertaining, and that's number 9 here, which is a British television company that had a system in which you could monitor the presence of the football on the field all the time. So it was revolutionizing how we can watch football and how we can televise it. There was only one problem, and that was at some point, the camera started following the referee instead of the ball. And if you look at the picture of the referee that I have here, you can maybe imagine that looked from above, he had a hairstyle that very much looked like a ball. And so those are the kinds of mistakes that algorithms make, but humans would never, ever make. And so my question is, how do we build systems where those kinds of failures don't happen and where humans are integrated into the systems? And that's what I call human in the loop, or human-centered AI. So there's an entirely new branch of AI systems emerging and algorithms that are emerging now, in which we think of AI as a tool for human processes. And so one of the really powerful concepts is that within human-centered AI, we can aim for high degrees of automation and high degrees of human control at the same time. Usually we think of sort of either giving the machine control or having, and then getting lots of automation. But Schneiderman and others say that we can actually, using these algorithms, achieve both at the same time. And that's very powerful. I have another approach to this, which is sort of the magical combination, I think, of hybrid intelligence between the disruptive potential of AI, saying we can just reimagine everything, and then the human-centered approach of having these algorithms. I don't have time to get into these concrete algorithms, but the names of the algorithms would be something like interactive machine learning, and active learning, and processes of and interactive reinforcement learning. So it's variant or inverse reinforcement learning is also something where we really start to go away from the notion of a cost function into something which is a hybrid human AI system in order to design these systems. So that was the technical part of it. And I'll just give you a couple of examples from the real world of how we are working with companies, not just to develop the technology, but to develop the integration strategies around that. And so this is what has happened from 2013, when people said AI is going to take over the world and it's going to take over our workplaces, to 2022, when even McKinsey is starting to say the future of AI is hybrid intelligence. We have been exploring hybrid intelligence over the past couple of years in workshops and roundtable series with IBM and Microsoft and other companies. And what we then have is the emergence of a concept where we are taking human skills and management procedures and artificial intelligence and merging all of those into a joint procedure. And we have some founding principles around that. And these founding principles are one, diving in and being very human-centered in the AI algorithmic deployment, but then also a number of management-related and deployment-related strategies that need to be done. And one of the really important things is, I'll show it with an example in just a minute or so, is that we need to think much more about the skills of the employees that we are building systems for. And we need to think about how we can build systems to upskill the employees. And once we upskill them, our task is not done. As systems engineers, we really need an AI and hybrid intelligence systems engineer. We not only need to upskill the employees and make the systems that work, we also need to ask the question, what kinds of new monetization values or business flows could we enable if we now have our employees challenged to the most and using all of their skills? So let me just show you very briefly sort of why, when hybrid intelligence is needed. It's really mainly when you have these kinds of soft skills like creativity, intuition, sensibility that are sort of at play in the workplace. I don't have time to talk about this, but I think it's really fantastic concept that is emerging now, that on the human side, there's something called thinking fast and slow. And there's also a trend now that when we design systems and AI systems, we should also be thinking whether machines should be thinking fast or slow. So intuitively, or being very considerate, deliberate about what they are doing. You can ask me about it. But I just want to end this with a couple of examples from our work. And one of them is around generative design, which has been hailed as the future of how manufacturing and product design is going to be in the future. McKinsey says that, and NASA and Adidas and car manufacturers are starting to use this kind of process where the algorithm now generates thousands of different options to a certain set of optimization criteria. And then these amazing kind of new technology parts are emerging entirely out of the machine exploration of the space. So Autodesk is one of the big manufacturers or big producers of these kinds of generative design systems. And we have a hybrid intelligence project together with them. And why do we have a hybrid intelligence project together with them? Well, if you Google generative design, then one of the big top hits that you get is generative design is doomed to fail. And one of the reasons, there's a long list of reasons, but one of the reasons why it's going to fail is that people who are experts in the field, architects, designers, really don't work that way of just generating lots and lots of options. So we need to build systems that integrate into the way that creatives are working with this. And so one of the ways that we're doing that is that we're developing entirely new systems of architects and experts, creatives, training their generative design algorithm, in which, here's an example, a floor plan of a company building is automatically generated by the algorithm, but then the human expert can then start to click on parts of this, and then they can identify why they think this particular part is a good part or fulfills criteria. This can then be trained, and then slowly, iteratively, we are training our algorithm. So again, this shows how algorithms should not be standing alone, but should be integrated into the workflow of the human experts. Another very short example that we have here is from image processing, where from the real estate companies, pictures are taken of companies, of houses. They are being sent to an image processing unit, and then overnight it's being processed, and then it comes live when these three images like this here are being processed and then turned into this nice bright image that we have here. The company has tried to use AI purely to do the processing, but it turns out that there are a number of failures where, for instance, if there's a tree in the window in the background and there's a little bit of wind, then you have 3 exposures of that, and then it becomes a blurry image. And what is happening to the AI version 1 that they implemented was that the image developers simply just threw away the AI suggestion, and then they started manipulating their own. And what we are trying to do is to build what you can call interactive machine learning systems, in which, just like in the previous case, the experts can start to draw on the suggestion they got from the AI and say, this is the part where it has failed, and I want something different exactly there, but I will keep all of the rest. So you're starting to build integrated workflows with that. Again, we are working sort of full stack with the companies, not just working on the tech solutions, but also about, so here is an example of how off-the-shelf AI fails, but we are building these kinds of systems where interactive machine learning can be used for that. But another example is that we are also asking the question, once the AI is taking the most trivial tasks, what kinds of new business opportunities could we think of? And this thinking of the new business opportunities is not something that the sales representatives can do because they don't understand the AI. So we need a new kind of breed who understand all of these kinds of processes. And here's an example that we could say that maybe a new model of specialization, mass specialization, mass customization enabled by AI would be that, for instance, customers could say, I want a special image that now has really sort of atmospheres or feelings that are conveyed to the user, but something that is not something that off-the-shelf AI can do, but that creatives can do. The last example that I just want to give before I stop is within corporate decision making. There's a lot of so maybe one of the holy grails within AI and then businesses is, what if we could get an AI to really understand all of the business dynamics and all the choices that we are making, and sort of let's say in the end maybe run the business for us. And so that dream is something called applying reinforcement learning to the entire business decision-making processes. And this, of course, always fails. It's really hard. But what we're working on is, how can we build hybrid intelligence loops in which experts are interacting with machine learning algorithms on parts of this. So what is happening today in advanced business decision-making processes and business intelligence is that a CEO has to make a decision, for instance, whether to have a merger or acquisition of a particular company or a new kind of production line. And what they have is a number of experts and customers, and they get forecasts from them. They synthesize that, and then they sort of simulate what the business logic would mean for that. And then they try to make a decision based on that. And so what we are working with several companies on is then to, first of all, build a feedback system for the experts so that they get metacognitive feedback on their expert predictions. So they will be told that they are typically a little bit biased, or that they have too conservative, or they have deliver too broad intervals. And then we're trying to implement a reinforcement learning agent that wanders the simulation space of what kinds of business decision-making processes we could take, and then gives the CEO advice on that. And at the same time, the AI is aware of where it is failing to have complete knowledge, and then applies active learning to probe the experts for some predictions when it is most useful. So those are sort of kinds of projects that we are working on. Here's the interface for sort of the metacognitive feedback. Here's sort of the dynamics that we're trying to explore with the decisions, whether you sort of go into a growth, or you look at your capital structure or your strategic initiatives, and then you can make various different decision-making processes in that. So just as a conclusion, what we're trying to do is now to come up with these kinds of questions that every part of an organization needs to ask themselves in order to have all layers of an organization aligned in such a technology transformation. And I just want to highlight a couple of them. For instance, it should be clear to any kind of an organization, whether you are building a human in the loop, or human on the loop, or human out of the loop, or human-centered AI system, or hybrid intelligence system. You should reflect on your potential AI failures when you design the systems. And then something which is more, you can say, untangible or less data-driven, you really need to think about how you create a psychologically safe space for your employees to be opening up and talking about what is it that I'm currently failing with in my current business. And if we have a narrative of human upskilling and saying that the main purpose of this technology transformation is not to be more efficient only, but also to upskill the employees, then that is going to be the hybrid intelligence pact that we call it, in which management creates this psychological safety for the employees. And that means that we can start to develop systems that work. And then the last question is, when you are freeing up human resources that are experts, we need to be better at asking creative questions about what could we be using these new freed up human resources and human capital for, in order to generate entirely new value chains and monetization mechanisms. And I think you are, as data scientists, not part of all of this, but you should really understand the mechanisms of this entire sort of full stack process in order to generate systems that work in the real world. With that, thank you very much for your attention, and I thank all of my collaborators for this work. Thank you.
Thank you so much, Jacob, for that. In fact, there were so many slides I was looking at and thinking that I wish that I had seen this presentation when we used to try to actually figure out so many problems at the workplace. So a lot of it also applies to what even people who are not using AI, I think, just generally using a lot of human intelligence can actually help solve problems. And this was extremely, extremely helpful. Thank you so much. I'll pass the questions on to Siddharth. Siddharth, will you take the questions for this session, please?
Actually, I'll ask a very different kind of question. And so a lot of the audience here is actually just students who are still in college, right? And our last few topics have been about kind of applied AI in an organization. So I think what we probably have here is a relatability problem, that we are talking about problems that they have no idea about and therefore can't relate to it. So I'd want you to take this challenge for a bit and tell kids why this matters, right? Because I think I'd also want to add one more sentence to it, that I think in real life, data science kind of destroys to some level the sexiness of AI, right? On one hand, we see AlphaGo, you did talk about applying AlphaGo to a real world problem. Then we see self-driving, and then you have recommendation engines, phenomenally unsexy. And so I think perhaps a great question for you to answer is that what kind of very interesting problems are opening up and will continue to open up, which don't need you to solve super high-end problems, but somehow bring a fantastic new dimension to how a regular problem is seen, and therefore should be interesting to everybody who's interested in the discipline and just doesn't see it as crunching a lot of data to come up with binary problems about the next click. Right?
Yeah. So a great question, and so my answer would be from the first slide that I had, where when you as a data scientist are educating yourselves, and then you're coming out as the first job in the industry, and then you are sort of very, very tech optimistic, and you sort of come out and you say, I have the solution because I sort of have been testing it. Then what I'm trying to say here is to be prepared and to be humble about these kinds of complexities that exist in the real world. So it's really good to, you should educate yourself, you should know all of the technologies, but then you should really understand that technology is not the entire answer to more or less any real world problems. And so that means that one of the things that you should really be focusing on is, alongside acquiring the technical skills, is to be able to have an equal conversation with people who are experts in other fields. And so I think that's one of the things that really can risk happening at the moment, is that we are so emboldened by all of the AI promises and the data science promises and the sort of the hype around this, that we start to believe that AI is the solution, and sort of deep tech solutions are the solutions to all problems. And then we might have a tendency to overrule people. But what I'm trying to say, if you take one message home from this, then is, when you come into your first real world application, listen to the people who have been working for 20 years on that kind of industry. Try to understand it and try to really understand what they're saying. And then once you really understand all of their objections, then we can start to develop systems that work. And this is really if I have to say what I think is the most exciting challenge that is in the next decade or two, then it is solving the problem of upskilling. So solving the problem of generating technology solutions that makes humans better at what we are good at, rather than replacing them. So a tech solution should not be something that just tries to look at where I can automate something, but really diving into what it is that fulfills people, challenges people, creates a sense of flow in the workflow of people, and then creates systems that support that.
Okay, let me ask another question which has been posted, but I'm not sure I actually understand it. It says, can you expand a little bit more about reinforcement learning and how humans reinforce algorithms and vice versa?
Yeah, so reinforcement learning is this dream of turning everything into, so it's very good. So you can take chess as an example. The rules are entirely clear, and the action space is entirely clear, and then reinforcement learning is a way to explore that space. And now the problem arises when you take that kind of a methodology and then apply it to a real world problem, where I talked about this reductionist approach, that sometimes data scientists, and I'm falling into the same trap sometimes also myself, is that we believe that our model is the world. And that means that we believe that a solution to our model is also a solution to the real world problem. But there are a number of simplifications that we made in order to create a system in which all actions are specified and all consequences of actions are specified. And in that simplistic model, we can have reinforcement learning. But what I mentioned is that if you apply it to the real world, then you need mechanisms such as interactive reinforcement learning, in which humans are sometimes probed about the actions and give some common sense or expert knowledge into the system, so that we continually make sure that the kind of computations that are being done are in line with the real world.
Lovely. Thank you very much, Jacob. I think with that, we thank you very much for having come for this one today. And we hope to have you again in the near future. And thanks a lot.
Thank you very much.